Hello everyone and welcome to my channel. My name is Arif, and in this course of circuit analysis we're going to have a very in-depth look at voltage divider and current divider, and what are the concept of voltage divider circuits and current divider circuits and when to use them in circuit analysis. We're going to solve some problems and hopefully you will have a thorough understanding of voltage divider and current divider circuits. So let's have a very basic look at voltage divider problems. What is a voltage divider circuit? If we have a voltage source, uh, let's call it just K, and two resistors R1 and R2. We want to figure out the voltage of VR1 and the voltage across R2, which is VR2. How do we figure out VR1 and VR2? A good way is to calculate the total current of this circuit. Why? Because if I have the current, then I know VR1 based off the Ohm's law is R1I. Let's just write it down. VR1 is actually R1 times I. And with the same method, VR2 equals R2 times I. And the current is the same for R1 and R2 because they're both in series, and we know that when resistors are in series, the same current passes through them all. In order to figure out VR1, we know R1. All we need to know is the current I. How to figure out the current I? Again, based off Ohm's law, I equals V over R. In this circuit, V is the value of the power source, which is K, and R actually is the equivalent resistor. The equivalent resistor here is R1 plus R2. So now we can substitute this I into these two formulas. As a result, we have VR1 equals R1 times I, which is K, over R1 plus R2. On the other hand, VR2 equals R2 times current, which is K, over R1 plus R2. Have a look at these two. There is something interesting to figure out here, and that is the fact that the voltage across R1 is R1 over R1 plus R2 times the power source, and voltage across R2 is R2 over R1 plus R2 times power source. You can memorize this formula because you can use it in so many voltage divider problems. Regarding voltage divider, if I have a power source of 9 volt and two resistors, let's call them 2 ohms and 4 ohms, how do they divide this voltage, this 9 volt voltage, between them? Let's call this V of 2 ohm and this voltage V of 4 ohm. V of 2 ohm equals, as we just mentioned, there is a direct relationship between resistor and voltage. So if 2 is half of 4, I can very quickly come to the conclusion that the voltage of 2 ohm has to be half of the voltage of 4 ohm. I can tell you shortly that the voltage of 2 ohm is 3 volt and the voltage of 4 ohm is 6 volt. But let's figure it out. The voltage of 2 ohm based off the voltage divider rule is 2 divided by 2 plus 4 times 9. And the voltage of 4 ohm, again based off the voltage divider rule, is 4 divided by 2 plus 4 times 9. Yeah, if we calculate them, this one is 3 volt and this one is 6 volt. Nice. Okay, now let's solve this problem. A voltage divider is made with R1 equals 1 kilo ohm and R2 equals 2 kilo ohm connected to input voltage of 9 volt source. And we have a load. A RL of 3 kilo ohm load is connected in parallel with R2. Find V out. So let's just try to draw this circuit. V in is 9 volts and we have R1 1K 1 kilo ohm and R2 is 2 kilo ohms. And then we have a load which is 3 kilo ohm. When you draw the circuit, you make it much easier to solve it. What is asked in the question is the V out, which is the voltage of the load. Let's call it VO. How much is this VO? In order to figure out the V out, let's just make it a little simpler. I know that this 3 kilo ohm is in parallel with this 2 kilo ohm. So 3K is in parallel with 2K. Do you know the answer? Yeah, it's 3 times 2 over 3 plus 2 equals 6 over 5 kilo ohms. I can just simplify my circuit. It becomes 1K and 6 over 5 is 1.2, right? 1.2K. And this is 9 volt. And this V out applies to this point as well because they're both in parallel and the voltages are the same. So I can say I still have V out here. And now we can use the voltage divider. V out equals R2 or 1.2 over 1 plus 1.2 times 9. That gives me, let me just calculate it quickly. The answer is 4.91. I hope it was easy after explaining the voltage divider rule. Okay, now let's make it a little more complicated. We want to design a voltage divider where V input is 10 volt, V of output is 5 volt, and the total resistance R1 plus R2 is 10 kilo ohms. I don't have R1, I don't have R2. That's what the question is asking for. Find R1 and R2. The only known in this problem is that I know the input voltage is 10 volts and I know I have R1, I know I have an R2, and I know they add up to 10 kilo ohm, and I know the output voltage is 5 volts. Let's consider the output voltage on R2. VO equals 5. From voltage divider rule, we know that this 5 volts is R2 over R1 plus R2 times the input voltage, which is 10. Okay, now we have some better ideas. I can say 5 times R1 plus R2 equals 10 times R2. We can cross out these two and this becomes 2R2, and there's 1R2 here, 2R2 at the right side. I can come to conclusion that R1 plus R2 equals 2R2, and from there I have R1 equals R2. Nice. I know R1 equals R2, and I know one more fact, that R1 plus R2 has to be 10 kilo ohms. There is only one solution for that. R1 equals R2 equals 5 kilo ohms. That was voltage divider, and you guys can solve more problems in this regard in order to master more and more. Now let's jump to current divider. With almost the same method, using Ohm's law, we can very quickly figure out current dividers. For current divider, the resistors has to be in parallel. R1, R2, and let's call the power source K volts. As you know from Ohm's law, we have I equals V over R. If I consider the current I flowing out of power source, as I said before, it has to peel off into I1, which is I of R1, and I2, which is the current flowing into resistor number 2. If we want to calculate I1 using the Ohm's law, I know that the voltage of R1 and the voltage of R2 are the same because they're in parallel, and they're the same as the voltage of power source. So I can say I1 equals K over R1, and I2 equals K over R2. I hope you agree so far. And we also know that K, which is the voltage, equals I times R. This is again from the Ohm's law. But here, as we are calculating the total circuit, this R has to be the equivalent R, which is I times, we have two resistors in parallel. As we said before, to calculate the equivalent resistor of 2, that's R1 times R2 divided by R1 plus R2. Okay, let's just try to make it a little more simple. That's I R1 R2 divided by R1 plus R2 equals K. From here, I want to just put this K, I want to substitute this outcome into each one of these currents. Let's see what is the outcome. From the first one, we have I1 equals K, which is I R1 R2 over R1 plus R2 times 1 over R1. So if we cross out R1 from numerator and denominator, that becomes R2 over R1 plus R2 times I. That is I1. And with the same method, we can see that I2 equals R1 over R1 plus R2 times I. This is the formula for current divider that we're going to use it in related questions of current divider. Okay, now let's solve some questions. Let's make this one, let's consider that a current source instead of a voltage source, and we consider it 3 amp, which is flowing into two resistors of 5 ohms and 10 ohms. Can you very quickly figure out I of 5 ohm and I of 10 ohm? From Ohm's law, we know that I equals V over R. So there is an indirect relationship between current and resistor. That means the higher the resistor, the lower the current. If 10 ohm is twice 5 ohms, I can come to conclusion that the current flowing into 10 ohms has to be half of the current flowing into 5 ohms. If you agree with me, the current of 5 ohms becomes 2 amp and the current of 10 ohms becomes 1 amp because there's an indirect relationship between resistor and current. The higher the resistor, the lower the current. But let's calculate it from current divider formula. I of 5 ohm, as I just said, is the other resistor, which is 10 ohm, divided by the addition of two resistors, 10 plus 5, times the source. That would be 30 divided by 15, which is 2 amp. On the other hand, the current of 10 ohms is the other resistor, 5, divided by 10 plus 5, which is 15, times 3. That's 3 over 3, which is 1 amp. Same result with two different methods. So I hope that you enjoyed the video. Please don't forget to like and share the video with your friends and help each other grow together. Thank you very much, and you can always reach out in case of any questions or hesitations. Have a wonderful day, everyone.